Okay, so we said that when you have APR and some number of compoundings every year, you start with the straight division. You start with the straight division. So quarterly, you start by dividing by 4. This is conflicting with everything we've learned about percent change. By taking that 9% and dividing by 4, but for APR, that's what they do. So we took, to now get the true annual percent change, it's going to be 1.0225 to the 4th. That will be the annual growth factor from which we can get the true percent change per year, which is 9.3 instead of 9. Okay, how do we do on this this one? Jessica, how'd it go?
I just took 1.0075.
1.0075
To the 12th.
and what does that represent? That thing to the 12th?
How much it is in a year.
Annual growth factor, okay.
And then I got 1.094.
Is there a
It's 938.
938? Let's do that. Percent change per year?
9.3.
9.3?
Or 938.
Yeah, let's get that 8 too. Okay, so does it make sense? This thing with APR is a little, but this is what they do in the real world. When you get a loan for a car or a loan for a house, this is what they do. Okay. So be aware of that. You even sign when you're signing, like you do all the docs. There is a sheet, like the law mandates that they give you this sheet to sign that says you're aware that the true percent rate that you're getting is not the APR. By law, they have this sheet that you sign, okay, as part of all the paperwork that you do to sign to get the loan, okay? All right. So these two things, this 9.3% on the quarterly compounding and the 9.38% on the monthly compounding is what's called APY. APY is the true rate of return, the actual percent increase per year for a given APR and compounding scheme. So APR is the initial number that you have, which you have to combine with compounding to get any kind of true rate. You have to divide by 4 quarterly to get the true quarterly rate, divided by 12. And that's the one time when we break the rules. Then you can work backwards and get your true rate of return. And that's called the APY. So there you go, more practice. So let's practice on these, and I will write all these down. I'm going to go out of the PowerPoint and take attendance. But you're going to find, so here's the APR schemes. Now you're going to do the same thing we just did. Figure out what would it be annually. What's the true percent change annually? Okay, as we saw, it won't be 7.5%. So you're finding the APYs or the true percent change. Is the task clear? This is just like what we just did. Okay, but you got more examples. Okay. Okay, let's just write I'm not going to go through them. Let's just write the answers down. What'd you get for the first one? 7.647?
Just 7.64.
Concur with that? Agree? Some other people got that? Thumbs up. 4% weekly.
4.07%.
Agree with that? 29% monthly. 4.24 or 2.5? Agree. You guys doing these? Look at graded homework later. Look at graded work later. Don't spend time in class. Focus here and look at that stuff later. All right. 18% daily. Go ahead. Nice and loud.
19.7.
7-1. Okay. Are we in agreement? Got a nod in the back. Got a nod here. Okay. So if you're not getting these, if you didn't get these, then you need to go back and review these problems that we just did. Watch the video. I'm not going to take time to go through those. But this is the idea of APR versus APY. What's the number that you care about? APY. That's the true percent per year, which is not reflected by APR. Well, it's reflected by APR, but it's not the APR. APR is not the true percent per year. When you start chopping up the year and compounding, that APY is going to be higher. Okay, so let's say that we got okay, suppose you make an investment of 15% APR compounded monthly. How much will 10,000 be worth after 7 years? So what do we really need to know to answer this question? We want the APY, okay? So let's walk through that. What do we do first? Yep, you're going to take, so let's do it as a decimal. Ready? So 0.15, that's our APR. We're going to start by getting the true monthly. That's the true monthly percent as a decimal, right? That's the true monthly percent as a decimal. And from that we want, so what is that? Nice and loud.
0.125.
We got it? Is that right?
Yes.
Okay, and what do we want to do now? Take that to the 12th power. No, we want the monthly growth factor. Not, this is the percent change as a decimal. We need the monthly growth factor. So we're going to add 1. So we're going to take this number that we got, which was the percent change per month, and add 1. Right? And that'll be 1.0125. And what are we going to do? Are we going to take that to the 12th? And this whole thing will represent what? APY? Not APY. What will that be? Not APR. It's not an AP. We're going to take the 1 month growth factor and raise it to the 12th. That does not give us a percent change. That's the 1 year growth factor. That's the 1 year growth factor. So let's walk it over here. So you said it was 1.0125? Is that right? That's the 1 month growth factor. Then we raise it to the 12th, and we get? And that's the 1 year growth factor, which gives us 16.07% APY. True percent change, 16%. Okay? But if we want to know how much 10,000 is worth after 7 years, we don't really, what are we going to use? We're going to use this, the 1.1607, right? Because that's the growth factor per year. So that's what this is right here. That's that 1 year growth factor. So how are we going to get how much that's worth after 7 years? Who has learned something in the last couple of weeks? Christopher.
10,000 times
10,000 times
1.1607.
1.1607, which I'm going to write this way. So this is, if this is the annual growth factor and we want it after 7 years, then we need the 7-year growth factor, which is to the 7th. Okay, let's find it. What is it? It's party time. That's what it is. This is a good little investment here. How much was it worth?
28,381.
Yeah, round to the nearest cent, right? Because that's what we deal in, dollars and cents. Is that correct? 1.3 or 1.4? 1.3. Okay. And that's reflecting what percent change per year? True percent change per year of 16.07, not the 15%. Okay, so some of you have maybe done compound interest problems in the past, and this is looking familiar, but you never saw it this way before. Oh, go ahead.
Couldn't you just give a step and just multiply 1.0125 to the 84?
Sure. So that's how many. Yeah, so you could just go right. Instead of doing the 1 year in between, you do the. Yeah, go right. But, so because everything's based on years, the compound interest formula is based on years. That's why I did that. But yeah, it's not wrong. Because this, yeah, you're right. So the 84. That's 84 right there. 12 times 7. Okay, so we just used the compound interest formula, but we did it all based on growth factors. So you may have not seen this before. So what is this right here? This is the per period rate as a decimal. And why do we add 1 to it? To get what? What's growth factor? Why do we add 1 to the per period, or that was per month, right? That was the per month rate as a decimal. And we added 1, and it gave us the monthly growth factor. All right, so there's one growth factor right there in those parentheses. That's the monthly growth factor. And why do we raise it to the 12? That's the annual growth factor, right? This is all stuff we did before, last couple weeks, or last week. So in red here, it's in red, or say in these parentheses, which I'll put in the brackets. Sorry, in the red brackets is the annual growth factor. And then what do we find? The 7-year growth factor. The whole thing, this whole thing is the 7-year growth factor. So and we know if you want to find the final amount after 7 years, you multiply by whatever that 7-year growth factor. So this compound interest formula now should make a whole lot more sense because it's just based on all this math we've been doing, exponential growth, this easy transference between growth factors. We talked about that Friday, right? If you have one growth factor in a situation, very easy to get another. And that's what's going on in this compound interest formula. You've got the monthly growth factor. Boom, you can easily get the annual growth factor. Boom, you can easily get the 7-year growth factor. Multiply it by your initial amount. Gives you the amount after 7 years. Okay, so the formula is then, this is called the principal. R is like the APR. It's the annual rate, like APR. N is the number of times you compound per year. So we're going to raise it to the N to get that whole thing is the annual growth factor, the yearly growth factor. Inside is the per period growth factor. And then we're going to raise that to the T. The T, and you get the T-year growth factor. And that usually equals the final amount, usually called A. Okay, so this was monthly. I want you to do the same problem. What will it be worth? Same, everything's the same except do compounded daily. Okay, so 50% APR compounded daily. How much will it be worth? 10,000 after 7 years. Go. So same thing daily. Don't just use the formula. Think through the process again. Just practice the process that we did to get that formula. Go through the process again. Thinking through every growth factor. Okay, so you'd start by finding the per day rate, which would be 0.15 over 365. And then you'd add 1, and that'd be the daily growth factor. And then you take that to the 365, and that'd be the yearly growth factor. Okay? So did anyone get just that? What is the yearly growth factor? So this is for months here. We're here. And then daily. So one point what? 20? 161. What's the daily percent increase? And just so you can compare your answers, what did you get for the amount after 7 years? Just so you can all have confidence. What was the amount after 7 years? Nice and loud. 573. Somebody else get that?
28,507.
See, I'm talking really loud. That's why you can hear me. If you talk in your normal voice, I cannot hear you.
Okay, it's 28,570 and 35 cents.
570 and 35 cents. Is that right? Is that accurate? Cool. All right, just so you can compare. 28,570 and 35 cents. Okay, to get there, we saw that what's the APY? Here are APYs. For monthly, notice 6.07. For daily, or 16. For daily, 16.1%. So, compounding more often results in a higher APY. So, does compounding more and more often just make it go up and up and up without limit? No, what's happening? It's kind of leveling off, right? So the APY is increasing, but it's kind of like converging on some maximum value. And that maximum value would occur. So the max APY, how often would we need to compound to get the maximum APY? What's that?
Fractions of a second.
Fractions of a second, he said. So we got daily, we could do hourly, we could do every minute, we could do every second, we could do a fraction of a second. Okay? So we can just keep cutting it up as much as we can. So the max comes from what we call continuous compounding. Meaning every single moment we do a little compounding. So it would be kind of like taking 0.015 and dividing it by what? Infinity. So the biggest number we could think of. Chopping up that annual rate into as many little pieces as possible, and then raising it to the infinity. So we chop that rate up into a zillion pieces, and then raise this to the zillion. Okay? This is the idea of continuous compounding, and it's your maximum APY. Everything else being equal. Okay? It's your maximum APY. Okay. So you see that you can't plug in infinity. You can't divide by infinity and raise it to the infinity. But we do see that it's heading for a number. So there's some mathematics between this and being able to calculate what it is for continuous compounding. So for continuous compounding, this formula becomes A equals P e to the RT. So if you have finite compounding, it's this formula. If you have continuous compounding, you need a new formula. And so it's based on this number E, which is called the natural base. The natural base, ran out of room here. Yeah. So the natural base E equals 2.7182818, and goes on and on and on. It's a number like pi. It's an infinite non-repeating decimal, very similar to pi, and it's called the natural base. So it comes into play when you have this, when you're talking about continually compounding something, rather than knowing how many times you compound per unit. Okay? In this case, per year. All right, so you get the natural base. Then R is the same thing. It's your APR as a decimal. T is the number of years, and P is the principal. So now, if this exact same investment had continuous compounding, you would do this. You would say the final amount equals your 10,000 times e to the 0.15 times 7. Okay, and your calculator has an E button, and when you hit E, it automatically gives you the caret, because the most prevalent use of this E is as the base of an exponential term. Okay, so it'll just give you the caret automatically. So you, in your calculator, do 10, and then find the E caret. Where's it? Second ln. Second ln, which is on the left side of the calculator, down towards the numbers. Second ln will give you E and a caret, and then in parentheses, you're going to put 0.15 times 7, and it should be very, very close to that daily, the result that we did when we did daily. What do you get? 28,000? Anybody got it yet?
28,576.5.
So going from daily to continuous over 7 years at 15% got us what? $6 more bucks? Is that what happened? So very close, right? So once we get to daily, I mean, basically, there's not much of a difference anymore. But this is still the very maximum you can do. The very best you can do is to compound every single moment. All right? And in order to, since you can't use that formula because you got infinity involved, you use this new one. So remember that R is our, what is R? That's like the APR. That's not the true percent change, or yeah, it's not the true percent change. It's this number like an APR. When you combine that with continuous compounding, then you get the APY. So what is the APY here? If you do e to the r, just do e to the 0.15. What is that number? So if I isolate this here, we know 7 was number of years. So e to the 0.15 equals what?
1.16183.
And what do you see there? What did we just find? Not the APY. The annual growth factor. So, because you can see, you're taking that thing to the, in this case, to the 7th. So that thing must be the annual growth factor if you're taking it to the 7th and multiplying by p. So e to the r then is your annual growth factor, which gives us that APY of 16.183%. Everything else being equal, that's the highest the APY can be when you do continuous compounding. Okay, so we will be back on web work schedule. So, and you have written homework for Wednesday, which I posted on Friday. So written homework Wednesday and web work. Yeah. Right, because it compares to over here. Our monthly growth factor, remember, was 1.1607. Daily was 1.1621. So now every moment, continuous, 1.16183. But you get it a different way because now it's continuous compound. Use that instead of that. Natural base. Natural base. Yes, sir.
I was wondering if you weren't here. I was talking to Jerem while you called my name. I didn't respond.